9a. Spontaneous emission. Radioactive decay occurs randomly and spontaneously. It is not triggered by external conditions such as temperature or pressure. Each nucleus decays independently, unaffected by how long it has existed. Decay is spontaneous, random in time and unpredictable for any single nucleus. Part B. 9b. Alpha particle composition. An alpha particle is identical to a helium nucleus. It consists of 2 protons and 2 neutrons. Alpha particles are heavy and positively charged. Part C. Cloud chamber. 9c. Part 1. Cloud chamber structure. Felt at the top soaked in alcohol. Alcohol evaporates into the chamber. Blackened metal base plate at the bottom. Solid carbon dioxide, dry ice, cools the base to about -78 degrees. A lamp shines in at a shallow angle so tracks scatter the light. A radioactive source is mounted on a holder inside. Cooling the base makes the alcohol vapor supersaturated. A fine mist of tiny droplets floats in the chamber. This cloudy layer is where alpha particle tracks become visible when alcohol condenses along the ion path. These parts together make a cloud chamber. Part C. Cloud chamber mechanism. Zoom into the supersaturated vapor to see how a track forms. Air and alcohol vapor molecules fill the chamber. An alpha particle enters and ionizes air molecules along its path. Alcohol vapor condenses onto each positive ion. Each condensation forms a tiny visible droplet. A chain of condensation droplets marks out the visible track. Many alpha particles are emitted at random angles and times. Tracks appear at irregular time intervals. The direction of each track is unpredictable. Track lengths are similar because alphas from one source have the same energy. Variable timing and direction confirm the random nature of radioactive decay. Part C. Spark counter structure. 9c. Part 1. Spark counter structure. Spark counter. Thin wire mounted a small distance above a metal gauze. High voltage applied between wire and gauze. A spark when ionization occurs. Part C. Spark counter in action. The apparatus assembles on the bench. A grounded metal gauze forms the base, with a radioactive source fixed beneath it. A thin wire is mounted just a few millimeters above the gauze, the detection gap. A high-voltage supply of about 5,000 volts connects the wire to the gauze. Zoom into that narrow gap to see how a spark forms. Air molecules fill the gap under a strong electric field from the positive wire to the grounded gauze. An alpha particle passes through and ionizes air molecules along its path. Liberated electrons accelerate upward, ionizing further molecules in a cascade. The air becomes conducting and a bright spark jumps from wire to gauze. Back at full scale, each discharge is registered and counted. Sparks appear at irregular time intervals. Irregular sparks confirm the random nature of radioactive decay. Part C. Part 3. 9c. Part 3. Half-life calculation. Initial count, 120 tracks. 15 tracks remain after 6 hours. N equals N0 times 1/2 to the power T over T. 120 to 60 to 30 to 15, 3 half-lives. 3T equals 6 hours. Half-life T equals 2 hours. Count the number of halvings on the graph to find half-life directly.